Number 4 was cos of 110 degrees. If I'm reducing it off the y-axis, it's going to be cos of 90 degrees plus 90 degrees plus 20 degrees, which is going to give me negative sine 20 degrees. Again, it is in the second quadrant, but my original function is cos, and my original function is negative in the second quadrant, which means that after I do the y reduction, sine is going to be negative. Number 5. Sine of 190 degrees is going to be sine of, now sine of 190 falls in the third quadrant, so to do the y reduction we're going to have to say 270 degrees minus, and that's going to be 270 degrees minus 80, which is going to equal cos, because it's a y reduction, sine becomes cos of 80 degrees, except it's in quadrant 3, sine is negative in quadrant 3, which means that we will end up with an answer of negative cos 80. Number 6, sine of 290 degrees is going to equal sine of 270 degrees plus 20 degrees, which is going to equal negative cos 20 degrees. Negative because sine in quadrant 4 is negative. Notice, keep in mind always that what's in brackets here is equal to that. Number 7. 10 of 165 degrees is going to equal 10 of 90 degrees plus 75 degrees, which is going to equal negative 1 over 10 75 degrees. Number 8. 10 of 230 degrees is the same as 10 of 270 degrees minus 40 degrees, which is equal to 1 over 10 of 40 degrees. Now this one is going to be positive because 10 of 230 means that we are working in the third quadrant, and 10, the original function, is positive in the third quadrant. Number 9 says that we are looking for cos of 346 degrees. That's going to equal cos of 270 degrees plus 76 degrees, which is going to equal cos becomes sine, negative sine of 76 degrees. Now I included one extra, number 10. I asked you, what is sine of 60 degrees? Sine of 60, wouldn't that be the same as sine of 90 degrees minus 30 degrees? Sine becomes cos of 30 degrees positive because we are working in quadrant 1. Sine is positive in quadrant 1. So far, we have been looking at angles that are between 0 degrees and 360 degrees. Now, let us take a look at angles that fall outside of that range. That is, angles that are negative or lie below 0 degrees, and angles that are bigger than 360 degrees. I want you to have a go at the following exercise. With each angle, I want you to sketch it first on a Cartesian plane before doing any form of reduction. Have a go at these, and when you return, we'll go through it together. The first one I gave you to do said sine of 362 degrees. Now what I'm going to do with all of these angles that are either extremely positive, that is they go above 360 degrees, or negative, I'm going to sketch the angle on a Cartesian plane. Remember, that's 0 degrees, that's 90, that's 180, that's 270, and that's 360 degrees. And it carries on. It doesn't necessarily have to stop at 360 degrees. We can just continue going on and on. So sine of 362, let's look at 362 degrees. That's 90, 180, 270, 360. We're not yet stopping. We're going a further 2 degrees over there. That means that sine of 362 is the same as sine of 360 degrees plus 2 degrees, which is equal to positive sine 2 degrees. The next one that we're looking at is tan of 380 degrees. Now tan of 380 degrees is going to be, again, start off at 0, 90, 180, 270, 360, and we need to go to 380, which is 20 degrees more than 360. That means that tan of 380 is the same as tan of 360 degrees plus 20 degrees, which is equal to positive tan of 20 degrees, because 380 falls in the first quadrant and tan is positive in the first quadrant. Number 3, read cos of 425 degrees. Now let's see where that is going to slot in. Cos of 425, so that's going to be 0, 90, 180, 270, 360. 360 all the way up till there is going to take us to 450. So it's 25 degrees less than that, which means that it's 65 degrees greater than 360. Yes, it is. So cos of 425 is the same as cos of 360 degrees plus 65 degrees, which is equal to positive cos 65 degrees.